Hi guys, the previous video has seen the basic things of how exactly the lines will be projected in the first quadrant. So in this video, going to continue with the problems. So let us consider the problem number 1. A line AB 18 mm long as its end A 20 mm above HP, 30 mm in front of VP, and it is inclined at 30 degree to HP, 45 degree to VP. So draw the projection of the line and find the apparent lengths and the apparent inclinations. So once the problem is given, so first you have to identify whether they given the true length or apparent length, whether they given the true inclination or apparent inclination. Then you have to check which point position they have specified with respect to HP and VP. So from this problem, you can see that a line AB 80 mm long. So they said that a line is 80 mm long. So that is nothing but, so 80 mm is the true length of the line, and the end A is 20 mm above HP, 30 mm in front of VP. So they specified the position of point A with respect to HP and VP, and they given the line is inclined at 30 degree to HP and 45 degree to VP. Means that are the true inclination of the line with respect to HP as well as VP. So what they asked to find out is you have to find apparent length and the apparent inclinations. So first go for the XY line, take the thickness as 0.13, draw the XY line and specify the line as X and Y. So once it is specified, so you have to define. So once you define that, so I have to specify which quadrant it belongs to in the position of VP and HP. So I want to specify VP and HP over here. So that's specified. You are solving the problem in the first quadrant. So once you've done the representation of the first quadrant and the XY line, that is intersection line, then you identify what is the position of A or B is the given. So the position of A is specified 20 mm above HP, 30 mm in front of VP. In the previous videos, I explained that the HP data comes in VP and VP data comes in HP plane. So when I'm going to take 20 mm above HP, that has to be drawn on VP plane. So I'll go for offset option, select single, select the XY line, and the dimension I'm going to specify as 20 mm. So I'm going to get the line on both the upper side and the lower side. So I'm going to specify that in the upper side. Go for left click. Then go for escape. So now I got a line 20 mm above HP. So that I want to specify as, you can specify the distance 20 mm, and I want to define that one as, since it is the front view of the point A, so I want to specify that as locus of A dash. Next, I'll go for again the offset option. So it is 45 mm, sorry, 30 mm in front of VP. So I'm going to select the XY line again. Go for the dimension as 30. Enter that. So I'm going to get 30 mm. Click on that. Go for escape. So once you've done that, specify the dimension. So go for again smart dimension. Specify that. So it is 30 mm. So I identify the another locus. So that locus I want to define as, since it is in front of VP, it is the top view of a line point A. So I want to specify that as locus of A. So once you identify that, select line option, select any points on these two lines. I want to specify that. So I want to draw a line between that two locus, and I want to specify that point as A dash, and this I want to specify as A. So now I have fixed the points A dash and A with respect to the locus. So the A point has been fixed. So other point B will be rotating based on the given conditions. Now for the given condition, they give specify the true length as 80 mm and angle they specified. So I'll go for assuming the first thing as it is inclined to HP and parallel to VP. So I'll go for A dash point. The true length is 80. So I'm going to specify as length as 80. Go for tab. The angle the given is 30 degree. So I want to go for enter. So I want to get the end point. At the same end point, you draw the line. So that line or that particular point I want to define as B1 dash, because that is the true length in its front view. So I want to specify that as B1 dash. Then that line I want to specify as locus of B I want to specify that one as locus of B dash. Then I want to project that B1 dash point downwards to the locus A to get the top view of that point, and I want to specify that one as B1. So this is when I want to assume the line is inclined to HP. So the inclination they specified is 30 degree. So I want to take angle as 30 and the given the true length as 80 mm. So both the things I specified over there. Now I want to assume it is inclined to VP and parallel to HP. So I go for A point and the length is 80. The angle I have to go for 45. Since I am going downwards, I want to take it as minus 45 degrees. So I will get the point. So I am going to draw again the locus at the end of the point where I am going to get, and I am going to define that point as B2, that is nothing but the true length in its top view, and that line I am going to define as locus of B. So once you got locus of B, from B2 point I have to get the top view of B2. So I want to project that it has to come to the locus A dash, and I want to define that point as B2 dash. So once you got B2 dash, so I will go for arc by center point to get the merging of both the conditions. So what I did is, first I assumed that it is inclined to HP, then parallel to VP. Then I assumed that it is inclined to VP, parallel to HP. So now I will go for, sorry, this angle I am not specified. I want to specify the angle. So this line and this line I want to specify it is 45 degrees and true length it is 80. So no need to show on both the side. So once you got B2 dash and B1, I will go for arc by center point. Select A dash as the center, B2 dash as the radius. I am going to draw the arc. I want to project the arc. Similarly, A as the center, B1 as the radius. I want to draw the arc. Now go for trim option and trim off the extra arc after the locus. So where exactly it is cutting the locus, that points I want to define as B dash in the VP plane. HP plane I am going to define that one as B. So now how are you going to define that it is exactly correct? So if I join B dash to B, if the line comes in an exact manner, then the problem will be correct. So if you are getting any disturbance over there, so that means somewhere it gone wrong. In this problem, just for your explanation I have shown. So what is the mistakes the student do is like this. So they won't connect the proper connection over there. So that things should be avoided. So now I want to correct that. So I want to select B2, exact endpoint you have to select. So you can see the endpoint. I'm going to select that and draw a vertical line. So now from there I want to draw the arc. Now you can see that you can get the exact point where the line will be joined in a vertical manner. So this you can see I'm going to get the exact dimension over there. So now it is the problem will be correct. So what I can do is take the line option, A dash as the center, B dash as the radius. I want to join the line. So this thickness I want to give as 0.5 mm, and I want to draw another line from A to B. That I want to give the thickness as again 0.5 mm. So I go for dimension, take the small dimension. So I want to get 56.57 and 69.28. That is the apparent length in front view and the top view. And I go for angle between. So I want to select this angle as 44 and this angle I want to select as 55 degrees. So this is how you can give the solution for the projection of the given problem. So one thing you have to remember is the thickness of the lines. So all the projection lines what I want to give is 0.13, and this XY line I have to go for 0.35, and the views, that is front view and top view, should be given a thickness of 0.5 mm. And you can write the values at the last also, or you can specify directly in the projection. So in the next class, we'll see the other problems on the line.